15. A large loaded passenger jet aircraft has total mass of 400 tons and is waiting at rest on the runway with the wheel brakes applied. All the engines are running and provide a total forward force of 600 kilonewtons. So if I just draw that here, what's happening is you have your aircraft, that's a plane, and its mass is 400 tons. So that's it there. And the force is 600,000 newtons. And the question is, what's the A? So what's the quickest way to get the A here? F equals ma. So therefore, A equals, so if F equals ma, then F over m is the A, so 600,000 divided by 400,000, so 1.5. Does Andy know? Oh, Andy. Wait till I tell you what you missed. We used, just for you, we used this formula.
Yeah, I also used it.
Good. And we also did it in our heads. Okay. B. Give me a reason why this acceleration cannot be maintained. Friction. Yeah. So, we have to write that as a sentence. As the plane increases in speed, so too will the friction. This will cause more drag. Remember, drag is the friction force that opposes your motion when you're driving. Oh, I said cause, but I wrote call.
I just was thinking of
Yeah, this will cause
it's like
more drag. Yeah.
sure what's that?
So too will the friction. Sorry, I'm using a complex structure there. I should really make it simpler. What I'm saying is, as the plane increases its speed, the friction will also increase. You want to make sure you get your A star for writing. Good use of complex sentence structure, you know. Alright, C now. As the plane increases in speed, so too will the friction. This will cause more drag. Yeah. Not drug, yeah, drag. Yes. Now, what happens now is the plane takes off. So here's the plane and it takes off. And if you watch carefully, this is, please note, 1 second. So in 1 second the plane goes from being on the ground to being up here. This distance is 75 meters, and this angle is 10 degrees. So this here would be 75 cos 10, and this here would be 75 sine 10. So therefore, for part 1, the height is 75 sine 10.
13.
Great. 13.02 meters. Part 2. Calculate the potential energy it gained. So that's mgh. What's the mass of this plane? 400,000 kilograms. So I got 511.04658 joules per second. Because remember, this is for 1 second. What's joules per second? Watts. And if you count off here, look, let me do it in red. There's 1, 2, 3, 4, 5, 6. So you could say it's 51 megawatts, if you like, which is actually what they ask you to do specifically in the question. See, if you look at the question. Now, what is the lost energy per second? Well, the plane gets 51 megawatts, but how much is the engine doing? 54. What example is this like that we just did today? No, with what? No. There's something.
Friction.
Guys, wake up. Do you remember the example I did where we pushed the block up the slope?
Yes.
It's the same idea with the plane and the engine making it go up this on its angle. So how much energy is lost? It would be 54.5 minus 51. So that is 3.5 megajoules per second, or megawatts, whatever you want to call it. Anyways, that's not what they want. They don't want how much energy is lost, they want the force. So how can you change it? What formula could we use? Work, force, multiply distance. So force is work over distance. So if I take this 3.5 mega,
It's not a work, it's a power, right?
yeah, you see, this is where you have to be careful. If you look at it as a 1 second process, then it is joules. But then you have to remember that's a 1 second process. I take your point, what you're saying here, but it's actually okay because you can just think about it as a 1 second journey, and then at the end when you get your answer you just say, okay, well this is being applied every second then.
Yeah.
Anyways, it's 3.5 megajoules in a second divided by the distance, which is 75, so that is 0.046 newtons of friction. Sorry, meganewtons, because I forgot we're in megas here. So that would be 46,666 newtons, or if you want, I think the nicest way to write it would be 47 kilonewtons approximately. A lot like the block being pushed up the slope. Okay, next now.